discuss the Earth subsystem or the systems of Earth. So Earth's four spheres includes Geosphere, Atmosphere, Hydrosphere, and Biosphere. The Geosphere comprises the solid Earth and includes both Earth's surface and the various layers of the Earth's interior. Atmosphere is the gaseous envelope that surrounds the Earth and constitutes the transition between its surface and the vacuum of space. Hydrosphere includes all water on Earth, including surface water and groundwater. And Biosphere is the life zone of the Earth and includes all living organisms and all organic matter that has not yet decomposed. So when changes in Earth system, which refers to Earth's interacting physical and chemical and biological processes, have finally settled, it was presumed that it evolved into four major subsystems: the Geosphere, Hydrosphere, Atmosphere, and Biosphere, that interact to carry out many different natural processes. So, motions of the ocean and the atmosphere have an impact on Earth's system too. But recently, scientists have been doing and noticing that other changes in the Earth motions or systems that are due to global warming, as well as changes in the way land is used and pollution may take place. These changes are changing the regular patterns of the system. The interaction of matter and energy was restricted within, and hence, Earth would have its own unique system, involving the interplay of physical, chemical, and biological processes, all made possible because of the composition and nature of its subsystem. So this explains that the energy is transferred between the Earth's surface and the atmosphere in a variety of ways, including radiations, conduction, and convection. Conduction is one of the three main ways that heat energy moves from place to place. The other two ways heat moves around are radiation and convection. This concept was actually proposed by Gaia Hypothesis, which states that an organism interacts with their inorganic surroundings and establish a self-regulating complex system that helps maintain the condition necessary to support life on the planet. So this statement, together with this image, explains that the living things are not only in the atmosphere, but they also help maintain the levels of gases in the atmosphere. So they helping maintain the Earth as well. So that is the idea of Gaia Hypothesis, that the Earth behaves like a living thing and maintain its temperature constant or relatively constant. For example, the rabbit breathes out carbon dioxide, the plant breathes that in, and then the plant releases oxygen. So this Gaia Hypothesis was proposed by James Newton, who was the father of Earth science. So let us now discuss what is a Geosphere. So the Geosphere is the solid portion of Earth that includes the interior structure, rocks and minerals, landforms, down to the deeps of the core, and the process that shape Earth's surface. All the continents and the ocean floor are also considered part of the Geosphere. So the Geosphere is very important because it defines much of the environment we live in, controls the distribution of minerals, rocks, and soils, and generates natural hazards that shape the land and impact humans. Without the geosphere, it would not be possible for humans to live on the planet because there would be no solid ground. Included in the Earth's geosphere are the rocks, the minerals, the molten rock, sand, and mountains. Mantle. The mantle is made up of solid rocks. This is the largest part of the Earth and makes up 84% of the Earth's total volume. It lies between the extremely hot core and thin outer layer, the crust. At the upper part of the mantle directly below the crust is the Ionosphere. The extreme temperature and pressure in the Ionosphere causes the rocks to become ductile and thus moves like liquid. The Ionosphere radiates heat from the mantle towards the surface of the Earth. So it explains that a Ionosphere is a part of the upper mantle just below the lithosphere that is involved in plates tectonic movement. When plates tectonic movement happen, it will result to earthquake, tsunami, and other geological processes. So how does a ionosphere affect the Earth? Heat from deep within the Earth, as you can see in our image, is thought to keep the ionosphere malleable, lubricating the undersides of Earth's tectonic plates and allowing them to move. Convection currents generate within the ionosphere pushes magma upward through volcanic vents and spreading centers to create new crusts or new islands. The rocks that make up a mantle are made mostly of silicate minerals. Common silicates found in the mantle included pyroxene, olivine, and garnet. The limited knowledge that scientists have on the mantle was derived from the sinolates or rocks embedded in another rock. So the silicate mineral is so important. For example, the only natural silica mineral used in significant quantities. So millions of tons are consumed annually by many industries. The sand, that is essential ingredient of concrete and mortar, is largely quartz, and they are silicate minerals also. The sandstone and quartzites are silicate minerals and used as building stones and making concrete hollow blocks. Crushed sandstone and quartzites are also used for road and railway construction. Okay, so relatively pure quartz, which is also came from silicate material, is required in large tonnages as an ingredient for glass and porcelain manufacturers. And high purity quartz is fused to make premium grades of chemical and optical glass. As you can see in our image, optical glass is perhaps the most common type material used in optical applications. In your eyeglasses, the lenses, in your Android phone, also serves as a product of silicate materials. The transitional boundary between the mantle and the core is known as the Gothenburg Discontinuity. It was named after its German discoverer, Benno Gothenburg. This boundary is not fixed because of the changes in heat flow. When heat in the mantle slowly dissipates, the molten core gradually solidifies and shrinks because of the process of cooling, moving this boundary deeper and deeper within Earth's core. So in the Earth's molten core, or the core of the Earth, the whole core was molten back when the Earth was first formed about 4.5 billion years ago. Since then, the Earth has gradually been cooling down, losing its heat to space. As it cooled, the solid inner core formed, and it's been growing in size ever since. But this process is very slow. It takes millions of years. The inner core only grows about 1 millimeter a year because the Earth has a rock mantle in between its hot core and its cold surface, which stop it from cooling down too quickly. Just like your raincoat or your coat that keeps you warm in winter. The slow cooling of our planet causes the molten iron in the outer core to flow and swirl fast as heat is transported to the mantle, and this gives Earth's magnetic field. Okay, so we have the presentation of layers from the crust to the core. So in the year 1913, Ben Gothenburg proved that the existence of the Earth's core, and he recognized that the primary waves or the P-wave shadow zone was due to the refraction and reflection of primary waves by the Earth's molten core. Eventually, this core mantle boundary was named after him. So the Gothenburg Discontinuity occurs within Earth's interior at a depth about 1,800 miles, or 2,900 kilometers below the surface, where there is an abrupt change in the seismic waves. So it generates earthquakes or explosions after the travel through the Earth. These deep primary waves or P waves decrease in velocity, while secondary waves or S waves disappear completely. S waves share material and cannot transmit through liquids, so it is believed that the unit above the discontinuity is solid, while the unit below in a liquid or molten form. So what is a core? The core is made up of iron and nickel. The iron in the outer core is in liquid form, which is why the iron core is known to be liquid, while the inner core is solid. So the inner core is solid because it's made of very dense or heavy material. Like iron and nickel, even though it is very hot, this material don't melt very easily, so they stay solid. It turns out that many materials can be a solid at higher temperature if the pressure is also higher. On the other hand, the outer core is liquid because it's hot enough to melt an iron, but only in places where the pressure is low enough, which is located in the outer core. As the Earth continues to age and cool, more and more of the core becomes solid, and when it does, the Earth shrinks a little bit. Okay, as you can see in our image is the representation of how the inner core and outer core varies in temperature. As you can see, the inner core has a temperature about 5,000 to 7,000 degrees Celsius, while in the outer core we have 4,000 to 5,000 degrees Celsius. So that makes the pressure is very high in inner core, and that is the principles of pressure freezing. It remains a solid in a very high temperature. The iron is particularly important because it is primary source of Earth's magnetic field. Similar to the discontinuities discovered in the outer layers, there is also a transitional boundary between the inner and the outer core. The Lehman discontinuity, which was discovered by Danish seismologist in 1929, Inge Lehman, when a large earthquake occurred near the New Zealand. Okay, so we have the representation of the whole structure of layers of Earth, and the location of the lithosphere, asthenosphere, mesosphere, the middle portion of the layers of Earth, the outer core and the inner core, and its respective distances, no? And also the specific measurement involves. So let's proceed about the hydrosphere, another subsystems of Earth. Hydrosphere is the total amount of water found on Earth. So this includes water in various forms, whether in ice, vapor, or liquid, found or below the surface of Earth, and in gas in the atmosphere. Water covers 70% of the entire surface of the Earth, and most of it is ocean. So this statement tells us that the ocean holds about 321 million cubic miles, or around 1.34 billion cubic kilometers of water, which is roughly 97% of Earth's water supply. Seawater's weight is about 3.5% dissolved salt. Oceans are also rich in chlorine, magnesium, and calcium. The ocean absorbs the sun's heat, transferring it to the atmosphere and distributing it around the world. The conveyor belt of the heat drives global weather patterns and helps regulate temperatures on land, acting as a heater in the winter and an air conditioner in the summer. So what is the principles of the hydrological cycle, also known as water cycle? So water circulates everywhere on Earth. This is made possible by the interaction of energy and matter that prompts the transformation of water from one phase to another, allowing it to circulate and travel to different regions of Earth. Water moves through the hydrosphere in a cycle. The sun's energy is the power that drives the water cycle. Light and heat causes water to evaporate from oceans, like rivers and other sources of surface water. So as you can see in our image and description of hydrological cycle, basically commonly known as water cycle, we can take water can take many forms. It can be a liquid, a solid, or a gas. Think about when ice cubes melt in your glass. That's an example of water in a solid form, changing into a liquid form. The water travels in a continuous path through Earth and its atmosphere, called the water cycle or the hydrological cycle. The journey begins in Earth's oceans. As the sun hits the ocean, the water evaporates, turning it into a gas. Sometimes this gas meets cooler air, and the gas changes into drops of water. This process is called condensation. Drops of water fall back down to Earth again as precipitation, which can be in the form of rain, snow, sleet, or hail. The precipitation fills up the rivers, lakes, and oceans, and the cycle begins all over again. Okay, so we have a picture of how water is being distributed around the globe. The distribution of water on Earth. All of the water found on Earth are natural, but not everything is considered safe for drinking. In fact, only less than 2.5% of the world's water is considered fresh water. The waters are divided into two groups, surface water and groundwater. Surface water, as the name implies, are waters found on Earth's surface, as opposed to groundwater, which is found below the ground. The surface water and groundwater also differ in type and amount of minerals contained in them. So, The distribution of water on Earth's surface is extremely uneven, as you can see in our image. Only 3% of water on the surface is fresh, or exactly 2.5%. The remaining 97% resides in the ocean. Of fresh water, 69% resides in glaciers, 30% underground, and less than 1% only is located in lakes, rivers, and swamps. So what is surface water? Surface water may either be salt water or fresh water. And salt waters have higher salt content and are found in larger bodies of water such as oceans, seas, bays, and gulfs. Fresh water, on the other hand, are those found in lakes, rivers, streams, springs, and falls, which, because of the lower content of salt, are the best source of drinking water for all organisms. So why can't people drink seawater? In reality, seawater is toxic to humans because your body is unable to get rid of the salt that comes from seawater. Your body normally gets rid of excess salt by having the kidneys produce urine, but it needs fresh water to dilute the salt in your body for the kidney to work properly. Can seawater may be drinkable? Yes, of course, in the process called desalination. Desalination is the process of purifying saline water into a potable fresh water, basically turning the ocean water into drinkable fresh water. Reverse osmosis and distillation are the most common ways to desalinate water. Groundwater. Groundwater, on the other hand, is the water found beneath the Earth's surface in the zone of saturation, where every pore space between rocks and soil particles is saturated with water. This area underground is called aquifer, a layer of rock that carry or hold water. So as you can see in our image, at the left portion, we have the recharge of water. If there is a rain, the water percolates to the ground, and every pore space between the rock and the salt particles is saturated with water. As it travels in the zone of aeration down to zone of saturation and distributed in water table, and the layers near the water table that holds a large amount of water is called the aquifer. So let us now discuss atmosphere. The primitive atmosphere of Earth may have been similar to the composition of the solar nebula from which Earth came from. Because of its exposure to various interstellar interaction, it eventually lost its primitive features to space. It was further replaced by compounds released from the crust and impacts of comets and other planetary objects rich in volatile materials. So these volatile materials creates the early development of Earth's atmosphere. It produces a bacteria called cyanobacteria that can be found in stromatolites. They are thought to be largely responsible for increasing the amount of oxygen in the primeval Earth's atmosphere. Through their continuing photosynthesis, they were first known organisms to photosynthesize and produce free oxygen. The oxygen they produce eventually creates our present atmosphere we have today. So, in the bottom, yung nasa ilalim na image na yan yung stromatolites that produces oxygen because they contain cyanobacteria. So how did Earth's atmosphere form? When Earth formed 4.6 billion years ago from a hot mix of gases and solid, it had almost no atmosphere. The surface was molten. As Earth cooled, an atmosphere formed mainly from gases spewed from volcanoes. It included hydrogen sulfide, methane, and 10 to 200 times as much carbon dioxide as today's atmosphere. After about half a billion years, Earth's surface cooled and solidified enough for water to collect on it. The first stage in the evolution of Earth's atmosphere. Original atmosphere was probably just hydrogen and helium. Hydrogen and helium are the abundant elements in the cosmos. Molecules of hydrogen and helium move really fast because they are gas with highly kinetic energy. The early atmosphere was probably dominated at first by water vapor. Then the atmosphere was dominated by nitrogen, but there was certainly no oxygen in the early atmosphere. Second stage in the evolution of Earth's atmosphere. The Hydrosphere was formed 4 billion years ago from the condensation of water vapor. The remaining oxygen accumulated in the atmosphere. As oxygen in the atmosphere increased, carbon dioxide decreased. No free oxygens at this time cannot be found in volcanic gases. Ocean formation as the Earth cooled, water produced by outgassing could exist as liquid, allowing oceans to form. Evidence: basalts, deep marine seeds in greenstone belts. A third present-day atmosphere. Some oxygen molecules absorbed energy from the sun's ultraviolet rays. These atoms combining with remaining oxygen to form ozone molecules, which are very effective at absorbing UV rays. The thin layer of ozone that surrounds Earth acts as a shield. Plants take in carbon dioxide and give off oxygen, while animals take in oxygen and give off carbon dioxide. Burning things also give off carbon dioxide. The present atmosphere is composed of 78% nitrogen, 21% oxygen, and 1% other gases, such as carbon dioxide, argon, and water vapor. So, the atmosphere is composed of various layers, which differ in thickness, temperature, and density. It is this layer that protects Earth from many external threats in space, such as impacts from celestial bodies like asteroids, meteorites, comets, and other heavenly bodies. And also the radiation. It protects us from radiation. It's like UV rays or ultraviolet rays and solar flares. The boundaries of the different layers of Earth were also established based on the temperature trends observed in each layer. So in this statement, it explains that each layer of the atmosphere has a specific protective function or importance in making the surface of Earth habitable for organisms. It is important then to improve our air quality by minimizing the emission of air pollutants and to avoid the destruction of the layers of the atmosphere. Let's proceed the first layer, the troposphere. It is considered to be the densest among layers of the atmosphere because of the weight of all other layers compressing it. Prior to reaching the next layer above the troposphere is a thin vapor zone called a tropopause. It differs from the troposphere in that it is relatively characterized by constant temperature. The temperature drops with altitude, and warm air on the surface of Earth rises readily in the troposphere. Air molecules travel up and back down, causing the formation of clouds and eventually rain from the moisture in the air. The vertical movement of air molecules also form air pockets that cause turbulence in this layer. Most of types of the clouds are in the troposphere, which can be as high as around 12 miles or about 65,000 feet near the equator, and 4 miles or 20,000 feet over the poles in winter. The bottom of this layer is at Earth's surface. Almost all weather variation occur within the troposphere. That is the reason why most airplanes or jets would fly slightly above the troposphere to avoid this turbulence and weather. No? Mas maiging iwasan natin yung troposphere because it can cause accident or plane crash. Next, the stratosphere. The air in this layer has strong, steady horizontal winds, which are advantageous to long-distance flights. At its upper region is the ozone layer at about 6.2 miles or about 33,000 feet above the Earth's surface. At the stratosphere is another thin buffer zone called the stratopause. This zone separates the stratosphere from the mesosphere. So, in the ozone layer, which contains a high concentration of ozone, there are different types of radiation that enters Earth's atmosphere. One type is the UVB, has been known to be hazardous as it penetrates directly through the protective layers of an organism. It damages their DNA molecules and thus may cause cancer. Without the ozone layer, most of the life forms on Earth would have perished. In the past decades, the ozone layer has been observed to be thinning. With further studies, it was determined that certain sprays and chemicals used in modern appliances use ozone-depleting substances or ODS that directly destroy the ozone molecules in the ozone layer. Most kinds of ODS contain chlorine. When these reach the stratosphere, contact with the UV or ultraviolet radiation causes the release of chlorine, which reacts with the ozone molecules. It is speculated that one chlorine atom can actually destroy 100,000 ozone molecules. Unlike other air pollutants, ODS are invincible and odorless, and hence were not immediately recognized to be depleting the ozone layer. Now these have been identified, ODS are banned all over the world. Examples of ODS are some hairsprays, insulating foams, refrigerants, and solvents. So, in terms of strategy, we have to maintain the proper way of burning of our garbages because it affects our ozone layer, for example. And we have this big idea that pag ginamitan mo daw ng large amount of gold yung ozone layer natin, pwede siyang bumalik sa dati. Mesosphere. Mesosphere is the thin layer above the stratosphere. The temperature here reaches a minimum of -90 degrees Celsius and is considered to be the coldest layer. The thin buffer zone above the mesosphere is called mesopause. This zone is actually the coldest region in the entire Earth. So the mesosphere is the layer maybe the coldest because the heat from the sun is decreased as absorbed by the thermosphere. So lahat ng init inaabsorb ni thermosphere. So that is why the reason behind the coldest temperature remains constant in the mesosphere. Additionally, radiative emission of carbon dioxide in this layer allows the absorption of solar heat and emits the heat back to space. The mesosphere is important in protecting Earth from planetary debris. This is where most of these spacecrafts like meteors get burned up or break down into smaller pieces. Next, we have the thermosphere. This is the hottest layer because it absorbs highly energetic heat from the sun. Depending on the solar activity, the temperature in this layer can rise higher and reach beyond 1000 degrees Celsius. This extreme heat causes the atmospheric particles to become electrically charged, making possible radio waves to bounce off and be received beyond the horizon. So as you can see in our image, the ionosphere, as part of the thermosphere, receives large amount of ionizing X-rays from the solar flare. So yung solar flare nanggaling yan sa araw or sa sikat ng araw. So it turns out that the ionosphere propagates signals and can be received by the transmitter and reflecting it through waves and receive it in the entire horizon. So yan yung dahilan kung bakit nagkakaroon tayo ng signal sa mga cellphones natin, sa Android phone, sa laptop, sa TV, sa radio, any kind of telecommunication system. So the figure is the Earth's magnetic field for the magnetosphere. It protects Earth from most of the continuously streaming solar winds. The solar wind ions stream by the Earth and most are repelled by the magnetosphere, and some are able to enter the ionosphere where auroras happen. So the magnetosphere is formed by the interaction of solar wind with Earth's magnetic field. The magnetic field of Earth is caused by currents of electricity that flow in the molten core. So these currents are hundreds of miles wide and flow thousands of miles per hour as the Earth rotates. The lower part of the thermosphere is the ionosphere, where most collision of oxygen and nitrogen particles are electrically charged by the solar wind. So the reason why most collision of oxygen and nitrogen are electrically charged by the solar wind in ionosphere because in the ionosphere, the speeding electrons collide violently with gas atoms. This gives the gas atoms energy, which causes them to release both light and more electrons. So how does the ionosphere protect us? The ionosphere is useful in many ways. It protects organisms on Earth by absorbing those harmful extreme ultraviolet rays. The electrically charged particles in the ionosphere also reflect some of the waves coming from Earth in particular. The ionosphere reflects radio waves also. Next, we have the solar wind. The solar wind is a stream energized charged particles flowing from the sun. The charged particles are called ions, consist of electrons and protons with high kinetic energy and high temperature of the corona. The ions which stream continuously from the sun's surface are called solar winds. As the solar winds gets blocked by the Earth's magnetic field, some of the ions are able to reach the ionosphere. So protons and electrons are made up of gas material, and being a gas can create high kinetic energy. So the sun's corona is the outermost part of sun's atmosphere. The corona is usually hidden by the bright light of the sun's surface. That makes it difficult to see without using special instruments. However, the corona can be viewed during a total solar eclipse. So the picture at the top represents the sun's corona image during total solar eclipse, as you can see it in our slide. So, what will happen to some ions that are able to reach the ionosphere? From the time ions are able to reach the ionosphere, then it immediately plays an important part in atmospheric electricity and forms inner edge of the magnetosphere. It has practical importance because, among other functions, it influences radio propagation to distant places on Earth. And radio propagation ang dahilan kung bakit nagkakatanggap tayo ng signals sa ating mga cellphones, laptop, TV at iba pang gadget na konektado sa radio communication or radio telecommunication system. Okay, so yung corona, yung nagdadala ng solar flares or nagbubuga ng solar flares na tinatanggap naman ng Earth pero hindi siya makakapag-direct contact sa Earth natin because of the magnetosphere or the magnetic shield na yan. So, dun lang napupunta yung solar wind or yung flares natin sa magkabilang poles. Alam natin na yung poles ng Earth, makikita yan sa North Pole at South Pole. At doon magkakaroon ng electrically charged particle na makulay. Yan yung tinatawag nating aurora oval na magkakaroon ng aurora appearances. Okay, so this image represents the pressure from the solar winds. The solar winds distorts the magnetospheres into a teardrop shape with a long tail leading away from the sun. Our magnetosphere repels ionized particles from the solar wind and protects us from damaging radiation. These particles are deflected around the magnetic field and on into space. So in the ionosphere, the solar wind ions collide with Earth's oxygen and nitrogen atoms. The energy released during collision causes a colorful glow around in the poles called auroras. Okay, so as the sun is a ball of super hot gases made up of electrically charged particles called ions. In the ionosphere, the ions of the solar wind collide with atoms of oxygen and nitrogen from the Earth's atmosphere. The energy released during this collision causes a colorful glowing halo around the poles. An aurora will appear. So what is aurora? Aurora occurs at about 60 to 620 miles above Earth's surface. The rate of intensity of aurora depends on the strength of the solar wind. Hence, during an intense solar storm, more visible color lights can be seen in the sky. So it depends on the intensity of the solar storm that creates or that produces solar wind, yung katingkaran ng kulay ng isang aurora. For example, collision with oxygen produces yellow and green colors. So it explains that the ions will collide with oxygen materials or oxygen as gas produces yellow, green colors, while the ions which has the collision with nitrogen produces red, violet, blue colors, for example. So in our figure, it represents Earth's magnetic field that traps solar wind ions that reach the ionosphere. In the ionosphere, the solar wind ions collide with the Earth's atmospheric atoms and molecules, which causes energy releases in the form of aurora. The aurora may be visible in high altitudes of Earth. If witnessed in the northern regions, like the Arctic Ocean and northern Canada, it is called Aurora Borealis or Northern Lights. If seen in southern regions like Antarctic and southern Australia, it is called Aurora Australis. And plus, if you ask me if there's aurora here in the Philippines, the answer is a big no. Because the Philippines is located in the equator, which the Earth's magnetic field does not emit from, but rather at the poles. So, kita lang natin yung aurora sa North Pole at South Pole ng mundo natin. There exists a thermal pose above the atmosphere, which serves as a buffer effect along with the Exosphere, and which separates Earth's atmospheric from space. The Exosphere is not considered as another layer, but it separates Earth's atmosphere from space. So although class, the Exosphere is the most distant layer and it is not considered as another layer of the Earth's atmosphere, it gives importance to the defense of the Earth's atmosphere. So it is also the first layer that come into contact and protect the Earth from meteorites, meteors, asteroids, and cosmic rays. So next we have the Biosphere. The Biosphere is a closed system that makes up all the living components of Earth. In this system, an organism can consume another organism to allow energy to circulate to the ecosystem. So this pertains to a food chain or food web, wherein an organism consumes another organism. Life exists in all subsystems of Earth. On land, Geosphere, there is life. In water, Hydrosphere, there is life also. And in air, Atmosphere, there is life exists also. So Biosphere is self-regulating system. So why is Biosphere is self-regulating? For example, the remains of dead plants and animals releases nutrients in the soil and ocean. So these nutrients are reabsorbed by growing plants. Then exchange of food and energy makes the Biosphere a self-regulating system. Kung ang lahat-lahat magpupunta lang, yung cycle na yun, magpupunta lahat lang dito lang sa mundo natin, sa surroundings natin, sa environment. So the figure represents the energy pyramid. Is built based on the rate by which food material in the form of energy passes through the food chain. Okay, in our image, it's the representation of oceanic energy pyramid. So the image of an energy pyramid is directly connected to food web, which is composed of several interconnected food chains that involves more organisms. The more organisms participate in this line of energy transfer, less energy could be obtained by the last consumer. As you can see in our apex, yung pinaka-top ng energy pyramid natin, lesser energy na lang yung ma-obtain ng apex predator natin. So pakunti ng pakunti habang tumataas yung pyramid natin, pakunti ng pakunti yung energy na makukuha ng bawat organism sa isang energy pyramid. So the energy pyramid demonstrates how energy diminishes as one organism is eaten by another. Food web exists in an ecosystem where both living and non-living things interact to make the whole system balance. Okay, so that's the end of our discussion, but before that, we have the big idea. The main importance of studying the interaction between the four subsystems is to understand how different aspects in nature correlate to each other. Studying the subsystems also show the effect of pollutions in nature. Okay, thank you for viewing. God bless.